Potential energy is the energy due to position. So if I'm looking at this, the highest spot is A. All right, so A is the answer because it is the tallest point. Okay, so if you remember, potential energy equals mgh. So the biggest height gives a greater potential energy. Okay, which positions represent the points at which the object has the same potential energy as point B? Well, point B here is at the bottom, right? So at point B, the potential energy equals 0 because the height is 0. So if we take a look, D and F are the other two. So D and F also have potential energy equal to 0 because their heights are also 0. Which positions represent the point at which the object has maximum kinetic energy? Well, we know that potential energy plus kinetic energy equals the total mechanical energy, right? So we want the places where there is no potential energy, and that's going to mean that kinetic energy is going to have all the energy of the system. Okay, so this is going to happen when potential energy is 0, and we know from number 32 that that happens at points B, D, and F. Okay, so what we also know is because this has a maximum kinetic energy, so remember kinetic energy equals 1/2 mv squared, we know at these spots that the velocity is its maximum. Okay, so it has the maximum velocity at all those spots as well. All right, determine the function of simple machines. All right, so a simple machine, such as an inclined plane, can be used to move heavy items easier by reducing the amount of force needed, but it requires you to push the objects over a longer or a greater distance. All right, so if we want to, we're going to be determining the mechanical advantage of the simple machines, and we're going to calculate the force required to move something with different types of machines. Okay, so looking at the incline, all right, this is our input distance here. So input distance equals 4 meters. This is our output distance. So this is without our machine, what's happening. So this is our output distance, and that equals 2 meters. And it wants to know what the mechanical advantage is. Well, the mechanical advantage, if you're looking at distance, is going to be the input distance divided by the output distance. So in this case, 4 meters over 2 meters equals just 2. So there's no units for mechanical advantage. Okay, so mechanical advantage here is 2. Then it wants to know the input force needed. Well, we know that mechanical advantage, not only does it equal the distance input and the output distance, it's also equal to the output force divided by the input force. Okay, now we're the input force, and so this force here must be the output. So what we end up getting is, if I'm looking for the input force, if I cross multiply, I know the input force is going to be equal to the output force divided by the mechanical advantage. So that's 40 divided by 2 from problem 35 here. And so that's going to equal 20 newtons. Now for 38, what's the mechanical advantage of this pulley? Now we don't include anything that we are pulling down, only if we're pulling up. But here we're pulling down, so the mechanical advantage is just the count of the string. So it's 2 because it has 2 support strings. So using this pulley, what input force is required to lift a 30 Newton block? So coming back to this equation, we know the input force is equal to the output force divided by the mechanical advantage. So that's going to be 30 newtons divided by 2. So the input force, what we're feeling is we're pulling down, is going to be 15 newtons. And then the last problem, we have this 1.5 and the 0.5. So this is our output distance, and this is our input distance. This is what we're going to be moving, this part of it. Okay. And using this lever, if you push down the lever with 5 newtons, what amount of force could you lift? Okay, so let's find the mechanical advantage first. We know that it's the input distance divided by the output distance, so that's 1.5 meters divided by 0.5 meters, and that's going to be 3. And then once we know that, we know if we push down, oh, here it looks like we're looking for the output distance, right? Because we're pushing down, so this is the input force. So we know mechanical advantage equals the output force over the input force, and we want to solve for the output force. So the output force is going to be equal to mechanical advantage times the input force. So that's going to be 3 times 5 newtons. So the output force is equal to 15 newtons.